Hi, my name is Gary Sullivan, and I'm going to be talking today about the restoration of the Dixon Waterfowl Refuge and about common carp and how they degraded the system and then how we put it back on the road to recovery. Prior to restoration, the site was in agriculture for nearly 100 years, as you can see here on the left. Part of the blueprint for restoring this system was taken from an 1896 map illustrating various habitats, including the footprint of the lake and marsh. We began in April of 2001 by simply turning off the pumps draining water from the site. And then, in partnership with the IDNR fisheries biologist, we applied Rotenone to the 6.5 miles of drainage ditches winding their way through the system. By August of 2001, the lake was just about full to its former extent, as was illustrated in that 1896 map of the lake, marsh, and other habitats. By 2003, this landscape had been completely transformed, with a 1,300-acre lake and marsh system that was very similar to that found over 100 years ago. To keep track of this development, we began surveying the lake and marsh vegetation by recording the identity and cover of each of the species in 100 randomly located 1 meter square quadrats, each September beginning in 2003. These were permanent quadrats that we resampled each year. We located each with GPS and accessed them by boat or simply by walking through the shallows. The lake at that time was already full of vegetation, with a diversity of marsh species growing along the shore, in the shallow water, and deeper. And many species, like this long-leafed pondweed, were producing an impressive number of seeds, setting the table for migratory waterfowl. By the spring of 2003, waterfowl and other wetland-dependent birds were already flocking to the site. And by 2005, a number of them decided to stay and raise a family. Here we had yellow-headed blackbirds nesting in the cattails, and pie-billed grebes nesting out in the floating vegetation. There were so many pie-billed grebes that year that they were taken off the endangered species list. However, in 2006, we were seeing evidence that the system was in decline. There were a lot of common carp, and there were lots of open water, with submerged species disappearing. It became apparent that the common carp, in their feeding behaviors, were digging up macrophytes, and at the same time contributing to the turbidity of the water, preventing new seedlings from germinating. And beginning in 2007, the entire system had begun to collapse with the loss of all the submerged species. Even hardy species like white water lily were beginning to disappear. So the decision was made that year, for better or worse, to try to remove enough carp to allow the system to jumpstart itself and recover. We hired a commercial fisherman to go out and remove carp, and they removed thousands of pounds, many thousands of pounds of carp. But it quickly became apparent that no matter how many they took out, they were only sipping a little bit off the top and creating a little bit more room for the next generation to grow into. So beginning in 2007, we also did a study of the carp population with Pajemic Bayer out of Peter Sorensen's lab in Minnesota. And he found the carp population had been relatively stable through 2004 until it began to increase rather dramatically. By 2006, it was having an impact on the lake, and of course, by 2007, the system was in decline. We have no data beyond 2007, but it was really beginning to increase exponentially. So to illustrate the impact of carp on the vegetation, we did an NDVI infrared analysis on Hopper Lake between 2004 and 2008. And that's the area inset on the right. So the analysis shows areas of dense vegetation in shades of red, and areas of little or no vegetation in blue. So by 2004, the system was nearly fully vegetated from shore to shore. But by 2006, the situation had changed dramatically, with areas open water developing due to the loss of aquatic vegetation. By 2008, however, the system was degraded to the point where there was only a few patches of American lotus and some scattered cattails. The system was in serious decline. By 2009, the entire system had evolved into an aquatic desert, and the only thing that was left was a few small patches of cattails barely hanging on. As I had mentioned earlier, we were doing an annual plant survey each year in September, and the data showed, as you can see here, through 2006, there were quite a high diversity of plant species being found, and even though 2006 was the year in which the lake first began to degrade. By 2007, those numbers had dropped dramatically, and by 2009, there were only 3 species found, with an additional 2 species found elsewhere outside of the quadrats. We also wanted to look at what impact this loss of vegetation had on migratory waterfowl, and we did this by looking at the data collected by the state's waterfowl biologists in their annual fall aerial surveys. And here you have the total richness of species surveyed along with the peak abundance for each species for each year. And you can see that the numbers really peaked in 2003 and 2004 in terms of the total seasonal abundance and diversity. The slight drop in 2005 may have been simply an off year due to fewer numbers observed throughout the Illinois River Valley. But by 2006, when the system was in decline, we see a large drop in the abundance of all species, except perhaps mallards in the top bar and American coots in the bottom bar. By 2007, we were seeing many species dropping out altogether, and even mallard numbers were down. By 2009, only 7 species were observed, and those in small numbers. Also of note is the observation that the coots were immediately responsive to the loss of vegetation, completely disappearing after 2006. So we were seeing that the impacts of carp on the lake and marsh vegetation was strongly reflected in the use days of migratory waterfowl. So we tried to put all this data together in a correlation to see what was going on with carp biomass. And in this top panel, you can see this is biomass in kilograms per hectare, which again, the last solid numbers we have is in 2007, but we're projecting the number to keep growing on pretty much the same trajectory. If you look in the second panel, percent plant cover really begins to drop off between 2005 and 2006, which is when we began to see the degradation of the system. To the point by 2008, there was virtually very, very little we were finding in any of the quadrats. At the same time, the number of quadrats that were completely bare sediment, that's with 100% bare sediment, they began rising rapidly until almost all the quadrats by the end of 2009 were actually just nothing but bare sediment. The plant richness at the site also began to drop off and follow the same pattern, as well as the waterfowl use days, here times 1,000. So by the fall of 2009, we had thrown in the towel. We decided to draw the system down and start over completely with a drawdown in 2009 and a carp treatment in 2010. So before we got started, we had a lot of really nice fish trapped in those drainage ditches alongside the common carp. So a rescue effort was mounted to salvage them, from the big guys like this northern pike to the littlest guys like this red-spotted sunfish, an endangered species in Illinois. Then in March of 2010, the system was Rotenoned by state biologists. And one of the things that I observed at the time, and I was thinking about quite a bit, but I wasn't really too worried about it because there were tile lines that were still draining water into the ditch system. But the conventional wisdom that from everybody I spoke to about this was that that water was pretty much low or had no oxygen in it, it being groundwater. So we didn't really think that would be anything that the carp could use as a refuge from the Rotenone. And then, of course, later on that summer, there was an explosion of vegetation, which made everybody feel really great. The only problem was that, as you can see here towards the bottom right of the picture here, the water quality wasn't all that great. We weren't really sure why that was. We weren't really seeing any carp, but the water looked kind of carpy. But the wildlife didn't seem to care. they came back in really large numbers, including many breeding species such as this family here of gallinules. When it came time to do the vegetation survey that year, we found a whole new problem. The density of vegetation was so high that it became really difficult to get around. By 2011, however, it wasn't so much a problem as a lot of that dense vegetation had disappeared, while water quality, and in particular water clarity, had dropped precipitously. And that crash in vegetation was reflected in the sharp drop in species found from 2010 to 2011, and then again in 2012. Based on the annual vegetation survey that year, submerged and floating leaf vegetation had all but disappeared, with only cattails and American lotus found in any of the quadrats. So in 2012, we made the decision to start over again, and we did. But this time, we decided to cap all those tile lines just in case carp were somehow using them as a refuge. But as the contractor pulled out the end pipes to set them aside, we were somewhat shocked to see that the water sluicing out had a lot of carp in it. It looked like we had found our reason why so many carp survived that 2010 treatment. And apparently we had. Beginning in 2013, we had crystal clear water filled with a diversity of submerged aquatic plants, from white water lilies at the surface to longleaf pondweed. We had a couple of different species of Elodea growing with some Myriaphyllum sibiricum, northern milfoil, and absolutely the biggest crop of sago pondweed we'd ever seen. And what we were seeing was reflected in our quadrat data, with more species than we'd ever seen before in the lake. By 2014, we were up to 24 species within our quadrats, with an additional 10 species found outside the quadrats. The lake was booming. And all that vegetation had a really significant impact on the migratory waterfowl visiting the site. Going back to the aerial surveys that were done by the state, we found that in 2013, the numbers just skyrocketed in terms of waterfowl visiting the site, where we had more than almost twice as many as we had in the highest previous year. The waterfowl clearly liked what was going on. And this is what it looked like in 2014. It gives you an idea what the lake surface was like. And in fact, that was the reason we stopped doing our annual vegetation surveys. It was so dense that we couldn't get around out there. But this was also a big reason why so many migratory waterfowl were visiting the site, to take advantage of the prodigious seed production going on. Here you can see the nutlets being produced by sago pondweed, one of the big attractions drawing them in. But everything wasn't all well. In 2018, we discovered a few large adult carp, even though the system still looked absolutely fine. We were beginning to see ever large numbers of spring migrants at the site, including tens of thousands of snow and greater white-fronted geese each year. But that high density of vegetation continued, despite the fact there were carp out there reproducing in the system. Here we can see that the vegetation in 2020 was still pretty dense and extending from shore to shore. And another really great thing to see was that we were getting quite nice development of hemi-marsh habitat in some of the shallower water areas. And this became a magnet for various waterfowl and other wildlife dependent upon these hemi-marsh systems. So here we are at 2023, and we have to ask ourselves, what happens next? The carp have been in the system since 2018, and most assuredly before 2018. And to this point, they haven't had any effect on the system. So going forward, is it going to stay this way, or will it change into something else? We don't know, but we will see. So this begs the question, why are those carp apparently under control now? And we don't really know with certainty, but based on conversations I've had with the fisheries biologists, we, and what I really mean is they, suspect it's because we established both a dense vegetation community and piscivore community before the carp population exploded. We also established a diversity of predators that could attack carp in multiple life stages, from eggs to fry to young of the year and potentially older fish even. And potentially other unknown factors that we only wish that we knew. And here are some of the actors that we believe are keeping those carp under control. Here's one of the many northern pike. But there are also other native fishes, like this spotted gar, and this relatively massive bowfin, one of the most voracious predators in this system. But not all predators are so big. Here is a fat and happy pumpkin seed sunfish that was surveyed by state biologists. This guy tipped the scales at 1.43 pounds, which is 0.07 pounds short of the world's record. A lot of these smaller guys are clearly finding enough to eat. And by the way, the state record for pumpkin seeds caught by angler is also from this system. So, kind of in summary, we have a tale of common carp at the Dixon Refuge. What did we learn? Well, we learned that common carp can quickly destroy a vulnerable aquatic system, and I mean quickly. Now, a lot of people may have known that already, but how fast it can happen within just 2 years' time was really astonishing. Then, getting rid of carp is really hard. It's expensive, and may require more than one effort, and it sure did with us. Carp are very adept at hiding to avoid rotenone, even in areas with very little oxygen, for example, those drain towel lines, which was a real eye-opener. Once the population has been eliminated or significantly reduced, ecosystem recovery can be really, really fast. And then establishing a strong, diverse community of piscivores before the carp population explodes is likely critical. And lastly here, ridding a system of carp takes a commitment, both an environmental commitment and a financial commitment in order to achieve. And with that, I will take questions.